Hey guys. So in the media today, it seems that a lot of people are confused about the strategies that we teach for math today for multiplication. Really, the traditional algorithm that your parents would have learned in school and I would have learned in school is still the goal. But what we want to do now is show them why that strategy works and what it actually means instead of just memorizing it. Some people are still really good at just memorizing a strategy and getting it down, and that's great. But other people really need it to be broken down so they can understand it. So, for example, if we had a question like 325 times 45, what we're doing here is we're timesing each part of 325 times 5 and each part of 325 times 40. So really what we're doing is 300 times 5, 20 times 5, and 5 times 5. And then we're also doing 300 times 40, 20 times 40, and 5 times 40. So in order to show that in a broken down way, what we're going to do is draw this kind of little window. So 325, if you break it down into its place values, is really 300, 20, and 5. We just broke it down into what each place value means. And then we're going to times that by 40 and by 5. So 45 is really 40 and 5. So we're just chopping this into different sections so you can see the breakdown of what your final answer will be. So here we have 40 times 300. So I'm going to do some tacking on the zeros mental math. 4 times 3 is 12. Then you can just tack on your 3 zeros. 40 times 20. 4 times 2 is 8. And then tack on your 2 zeros. 40 times 5, 4 times 5 is 20, and then tack on your 0. All right, and then remember, we have to times everything on top by 5 and everything on top by 40. So I put my 40 in my first row, so I'm already done with that, but we also have to times everything by 5. In the traditional algorithm, you would have done the 5 first. All right, so 5 times 3 is 15, and tack on our 2 zeros from the 300. 5 times 20, we should already know that for mental math, is 100. And 5 times 5 is 25. So now we have 6 different answers because we've shown that 300 times 5, 20 times 5, 5 times 5, and also 300 times 40, 20 times 40, and 5 times 40. So this would be shown in a shorter way in your traditional algorithm, but this just breaks it down. So now you have 6 different answers that you need to add together. And I'm going to go from biggest to smallest number just so that it's organized. All right, cross those off so I know that I've used them. Okay. And 125. So as you can see, I have all my 6 numbers. They are in order from biggest to smallest. So now I am going to add those up. 5 plus 8 is 13, plus 2 is 15, plus 1 more is 16. Carry my 1. Okay, so this is saying that my final answer should be 14,625. So let's go back to our traditional algorithm and see if that works as well. 5 times 5 is 25. So as you can see, I'm timesing 5 by everything up above. 5 times 2 is 10. Plus 2 is 12. 5 times 3 is 15, plus 1 is 16. So I'm going to cross these out because I've already used them. Now I need to put a 0 because I've already used the 5, and now I'm timesing everything by 40. It's not a 4, it's a 40. So I need to put a 0 to keep my place. 4 times 5 is 20. Carry my 2. 4 times 2 is 8, plus 2 is 10. 4 times 3 is 12, plus 1 is 13. Let's add it all together. Okay, so as you can see, the 2 answers are exactly the same. So there's no need for anyone to be confused or worried that this strategy is super complicated. It is complicated, it is long, but the whole point of it is just to break down this traditional strategy, which is our end goal anyway. But for some kids, and actually some adults, it is easier to see why we're doing this traditional strategy, because if you just look at how I did it this way, I could do this in my head really quickly. But if you look at my work, It doesn't really explain why this is the answer. So that's why we're doing strategies like this one that I like to call the window.